Hello, everyone. We're back with another interesting session, and thank you for taking time and joining us for this session. I'm Nitin, so I'll be your host and moderator for today. And today we will be probably talking about in a little more detail on transforming device integration specifically. And joining me is Steve and Bhavya. I'll just give you a quick sort of brief on both of the speakers today. So, Steve is the managing director at FDT Group, brings more than 30 years of global experience across business management, operations, sales, across organizations like BDO, Kramer Electronics, Belden, and Rockwell. So, yeah, hi, Steve. Really appreciate you being part of this.
Great.
And I have Bhavya with me with almost a decade of experience at Utthunga working on uh, different technologies like EDDL, FDT, FDI, with a lot of industrial automation vendors and customers over the years. So, hi, Bhavya. So, uh, a couple of quick logistics. So, what I'll do is just give you a brief for any first time attendees so that you understand how the session runs. It'll be a quick sort of Q&A for about 25 to 30 minutes, and we'll have a bit of time to take some questions from the audience to our speakers. And so feel free to drop in your comments, and I'll get to them towards the end and read them out for our speakers here. So let's cut to the chase, right? So I think it's important to start off with understanding some key areas around FTT technologies. And so, Steve, if you can maybe give us a quick brief on uh, FTT DTM technologies, as well as how the IC specific standards comes about, and the key sort of objectives you're trying to address as well.
Sure, that'd be great. Yeah, I'd be happy to. So listen, the FDT, first of all, that stands for Field Device Tool, and that's a specification that's actually managed by the organization that I head up called the FDT Group. And, we're a group of about 100 different members that are actually responsible for maintaining and enhancing the FDT specification. And that specification has an IEC number, which is IEC 62453, but it also has other mentions in GPT and other formats in other countries and regions. Okay. The main part of the specification is really this concept of something called a DTM. And the DTM actually stands for Device Type Manager. And the DTM is pretty powerful in that it actually contains all the application software that defines the parameters and the capabilities in a field device. And this could be either a sensor or an actuator that is actually deployed in the field as part of an automation system. These are used in both factory applications, so kind of discrete applications, and process applications. All right. So I think that's one of the things that's a little bit unique about a DTM is that it does support different types of devices. And those are both factory and process types of devices. Okay. It's a little bit analogous or similar to if you think about when you have a computer system, your laptop or a desktop or whatever it might be, and you've got different devices, okay, that can connect up into that. In fact, the top part of this picture here kind of gives an example where it shows, the drivers, if you will, for a printer or a mouse or a keyboard, okay? Well, a DTM is sort of that equivalent in the factory space for different types of devices, as I mentioned, and you can see a couple examples there. It might be a VFD, a variable frequency drive. It could be a flow valve. It could be a pressure transmitter, things like that. So the DTM is used for four main reasons. The first thing is to actually help design the system. DTMs can be pulled down and used independently on their own before even there's any hardware involved, with also for commissioning, operating, and then, of course, maintaining. And just a little trivia for everybody. Today, there are over 100 manufacturers that actually have devices that have DTMs. And that actually gets to about 12,000 different types of DTMs that are available today. And then, of course, there are tens of millions of those actually deployed in the field over the last probably 15, 20 years. So it's a pretty ubiquitous technology that's been out there for a number of years.
Great. So I think you briefly touched on the different industry applications and sort of widespread usage, right? So maybe if you can also shed some light on some of the key use cases that are solvable from this technology.
I'd say there's probably, happy to. There's two of them really, or two main categories, I guess I'd mention. One of them being industrial device management. And, that's around things like, how do you design the device in, as I kind of mentioned, how do you configure it? How do you commission it? What types of diagnostics and monitoring are you going to get back from that device? Are you going to establish or want to adjust any set points or parameters that are in the devices? And then it's really helpful from the standpoint of when you want to replace that device someday, you have all that information already stored. So you can easily just go ahead and drop in a pretty intelligent device with a lot of parameters and actually have all that information maintained. And I'd say that it's also used in, overall device asset management, So I think those are a couple of the key uses from a use case standpoint. In fact, if you go to the next slide, I think it maybe lists some of those. The other thing that it gets used for is also for data consistency and being able to integrate all devices using a common methodology, no matter who the manufacturers of those devices are. And it's one way to actually monitor and operate and look from a consistent standpoint, from a data standpoint, devices from different manufacturers, kind of providing an overall unified environment for people to actually see the information that's going on and actually be able to use that information in other applications that might be asset management applications or things like that as part of the control system. The other thing I'd mention about, and if you go to the next slide, I just want to share one thing with you, is I'd mentioned that DTMs are, and the FDT spec is part of a number of, standards organizations, and it's supported by those. But the DTMs also from a use case standpoint support, and they're sometimes we refer to it as communication protocol or network agnostic, meaning that you can see the host of network protocols here. A DTM is not tied in the FDT spec, is not tied to one specific protocol, whether it be HART or Fieldbus Foundation or Profibus, that it supports a bunch of different networks. And these networks are typically used, again, in different types of applications, not necessarily exclusively, but in factory applications. Some networks are more prevalent in factory automation applications, where other protocols are used more in process applications. And again, because of the flexibility of the DTM and the FDT specification, it enables us to support all of those different network protocols.
Awesome. So I think based on some of the points that you mentioned, right? So I'm sure there was real thought process behind bringing together a service provider program of sorts, right? And how they can possibly be leveraged on to sort of fast track some of this adoption of this technology. If you can shed some light on that, that would be fantastic.
Sure. Well, I'll tell you, I mean, one of the ways, and I mentioned, there's like 12,000 different DTMs out there that have been developed. Some of those obviously are developed by the actual vendors of the instruments themselves, whether it's the sensor actuator or, the device itself. But clearly, many of those are developed by development partners, what we'll call it. People that actually have been involved with and understand the FDT specification and how DTMs work. And obviously, Utthunga is one of those great partners that we get to work with, and I think have had a long-standing relationship with that does DTM work. Whether it's actually supporting a vendor or a manufacturer to make a DTM for them or helping them with that development. You guys are definitely very well knowledgeable about deep knowledge about FDT and also the DTM deployment and how that gets put together. So I think your experience and Utthunga obviously is, like, as I mentioned, one of the great partners that we have to work with. So, I know from an FDT standpoint and the standards organization, we definitely appreciate the work that Utthunga does and the fact that you've got all this experience and dedication to actually working with DTMs and helping deploy those for the specific purpose of actually allowing users to have a common environment that they can go ahead and manage their devices in. So although you're a development partner and you work closely, with the specification and with the FDT group, you actually provide a great service to the user community by working with vendors to do DTMs and help deploy the specification. So I know it's very much appreciated, and I know that's how people can actually realize the benefits of the DTMs when it comes to designing a control system, when it comes to commissioning that system, operating and maintaining that system, keeping those plants and those processes up and running. So Utthunga is just a great partner in actually making that happen.
Fantastic. Thanks, Steve, for that.
Sure.
I think that sort of sets the floor for Bhavya to come in and give in some of her inputs on how do we go about doing a lot of the stuff that we do for the vendor community, right? So I think, Bhavya, from your experience working with a multitude of different types of OEMs and vendors in this space, how have our team specifically work with the vendor community on FDT technology specifically, and how are some of the key sort of problems we've really addressed for them?
So, as Steve mentioned, we have been a partner working with FDT Group, being a spec and a work group member, and we have provided services over the past 15 years on various, DTMs. We also like develop a device DTM, the communication DTM for various protocols. We are into the gateway DTM development, and we have also supported some of the FDT host development as well. So these are the services which Utthunga is currently offering, and we have an option where we can, develop the DTMs from scratch based on the user requirements which we get from the FDS, the field device specification for the devices, or the UI requirements that they provide, and we ensure that the DTMs developed adhere to the FDT standards and the FDT user style guide, which is defined by the specification group.
Got it. So if I also understand clearly, right, like in terms of just having had a few discussions with some of the community members and the vendor organizations, uh, there is a need for DD and FDI files to be generated separately, and sort of having the maintenance of both the standards. There is we often do come across the vendor community asking about the maintenance aspects of both these standards and the cost involved, and how do you handle multiple source codes, for example, and how the whole thing can be streamlined. Uh, we have come across this quite often, and I know that you and your team have gone about solving these issues. If you can shed some light into how we've gone about addressing these problems, that would be great.
Right. The basic problem statement, what I would say is the various vendors, they have their EDD files, they have their FDI technology based files, the FDI packages, and they want provide a multitude of service, and they also want to pitch into the market where they can host that in the FDT hosts. So we have a tool that's called UDTM tool, which takes these files as the input, and it converts the EDD file, which is based on the EDD technology, or the FDI package, which is based on the FDI technology, and then takes those as the input files and converts it into the DTM format, which adheres to the FDT standards. It could be FDT 1.2 standard or the FDT 2.0 standard, and the output file generated can be hosted on various FDT hosts. And this is the benefit of this tool, where no, the time to market is greatly reduced, and the cost aspect which you just mentioned. So the vendors don't have to again invest in developing the DTM from scratch. So we can build on top of what they already have in terms of their technology and leverage it to the FDT technology using this tool.
Got it. So I think if I understand correctly, essentially this has been sort of designed as an accelerator to sort of give them a quick start approach to solving this problem of having to adhere to the standards that typically the vendors do come across, right? Maybe about the DTM UDTM tool that you were mentioning, if you can probably highlight some of the key features and the sort of supporting protocols and things like that, right? So that would also be helpful, I think, for the audience.
Yeah, at the moment, the tool supports FDT 1.2 standards and the 2.0 standards. When I say it adheres to these standards, the the DD or the FDI package which is input can be generated as a FDT 1.2 compliant DTM or FDT 2.0 compliant DTM, and it will also adhere to the FDT style guide which is provided by the specification group. And at the moment, the tool supports three of the protocols, that is HART, Profibus, and Foundation Field Bus for the FDT 1.2x version. And it also has features where you can host UIPs with direct access. It and the DTMs generated using this tool can the fetch the device health status and showcase it. It also allows the user to do the online and offline configuration of the device using the DTM file generated. It supports the upload and download feature, which is nothing but the store to device or load from device, which greatly helps solve the use cases like when you have to, do a the device replacement feature. And the DTMs generated, the main advantage here is it supports all the major FTT hosts from various vendors list which is there. So these are the key features which I would say. And as you can see here in the slide, we have also said that the DTM generated will not have just the EDD features. We can also offer some of the customizations, so that the DTM can be enhanced and there can be some additional features added to that.
Got it, got it. So I think you also mentioned about customizations. Maybe um, we do come across multiple requests on customers for aligning those DTs to the specific device types. What are some of those possibilities there, and this typical sort of request that you get from vendors quite often?
Yeah, so basically, we can offer two kinds of customization that is specific to device. We usually call it device specific, device type specific customization, and we also offer vendor specific customization. So when I mention device specific or device type specific, we have various level transmitters which support echo curve feature. So if the DD technology or the FDI technology, if that doesn't support this feature, we can add it as an enhancement, as I mentioned earlier, with the UIP feature. So the UIP can be integrated into the DTM, and that will be a customization offered for the level transmitters. Now, when it comes to actuators, we have to perform various offline diagnostic tests, something like a ramp test, step test, multi-step, or the valve signature tests. So all these can be combined as a UIP or can be added as a customization to those kind of DTMs, the DTMs for the actuators device type. And when it comes to flow transmitter, we can offer trunk linearization or the smart meter verification, all these features. And when it comes to IO modules, we can do the IO module configuration. And we also provide localization support. So when I say if the EDDL or the FDI package supports a single language, there is an option at the DTM side that we support the localization in the required languages for the users. And moving on to the vendor specific, as you know, each vendor will have their own logo or their own requirement or their own customization required for the for certain features. So the device header of the DTM and the about screen or the logo, the customized print feature, like FDT host usually supports print feature where you can view all the parameters. So that it's also a add-on feature or a customization that can be provided at vendor specific level.
Understood. So I know you mentioned it very briefly, and Steve did touch upon this as well, like in terms of the different communication protocols, and also in terms of the different FTT hosts that are typically available, right? So in terms of this particular UDTM tool that you use for conversion, what are some of these things that you come across in terms of the different protocols as well as the hosts that you have to adhere to?
So at the moment, we have supported three of the protocols. That is Heart, Profibus, and Foundation Field Bus.
Mhm.
And when we say these three protocols are covered, the FDT hosts that are available in the market, we support 15 plus hosts from various industry giants like Emerson, ABB, Yokogawa Systems, and the Anderson Hauser, Asbil. All these are the major FDT host developers, and their host systems we have supported the interoperability with. And coming to Windows operating system, we have various Windows operating system support starting from Windows 7 SP1 until the latest version, Windows 12. And we also have the DTM run on Windows Server systems starting from 2008 R2 version to Server 2019. So these are some of the offerings in terms of the protocol support, the host support, and the operating systems.
Got it. So if so, from the UDTM tool itself, like the DTM files that are typically generated from that, uh, are they certifiable directly, or is there a sort of intervention there that is typically involved?
So usually, as I mentioned, these DTMs which get generated from the tool are certified, can be certified using the FDT Test Center certification test cases. However, there may be slight changes required. So the coverage is around 90 to 95% that I would say FDT, the compliance perspective. There may be
Mhm.
slight changes, like 5 to 10% changes that may be required from the DTM side to ensure that it adheres to the test center's specification. But yes,
Got it.
definitely we can certify all the DTMs. It is certifiable using the FDT test center.
Awesome. So maybe one final sort of question, right? So in terms of the real sort of value proposition from the UDTM tool, in terms of how device vendors can really to sort of leverage on the full potential, the primary thing that I know we're trying to address is the timeline and the cost, and in terms of how do we accelerate that thing. But uh, uh, what is that sort of the figure itself, right? So ultimately, that's what matters based on whatever your experience with other vendors have been.
So our expertise is that we have supported 100 plus device types, certifying them. And when I say 100 plus device type, you can also think of the number of DTMs that we would have generated. So we have
Mhm.
around 150 plus DTMs that are generated and certified. And when you say this tool, it helps like early time to market, because the time taken to convert from EDD to or EDD or FDI technology to FDT technology is quick, and it doesn't need the need of 3 to 6 months timeline which we see in usual custom DTM development. We call it custom DTM development, where we develop the DTM from scratch, adhering to the requirement or the FDS that the vendors provide. So those are the few advantages and the numbers that we have achieved using this tool.
Understood. Awesome. So I think we've spent about close to 25 minutes on some insightful points, and it was almost like a quick fire session. So that was the intention, to see how much we can sort of get out of a short session, and be really specific to the point. So I really appreciate the effort from Steve and Bhavya to contribute towards this. And uh, if in case the audience has any questions, do feel free to drop it off in the comment box. We can always get back to you with the answers on the channel itself. And so so yeah, I think that's pretty much the end. So thank you again, Steve and Bhavya, for being part of this. We really appreciate this, and I'm sure we'll have you guys on board for a similar topic somewhere down the line. And so until next time, goodbye, and thank you, audience, as well, for being on board.
Great. Thank you. All right.
Thank
Thank
you.
you. Thanks,
Bye.
guys.
Thanks. Bye.